Good day. My name is Frans van der Merwe and I work for IBM in South Africa. I'm going to show you a demo and the different ways that we can deploy callable flows in App Connect Enterprise. I'm only going to make use of the synchronous option now, but it should be quite easy to make it work for the asynchronous option as well. To understand callable flows in App Connect Enterprise, we need to quickly discuss something we call switch servers and agents. Now, if you got a situation where there's a flow that's been broken up into different pieces, and those pieces are running in different integration servers, maybe distributed on-premise to different integration servers, or maybe some of it is running in the cloud and another piece is running on-premise. For these two flows to actually communicate and know where is the other one, the App Connect Enterprise makes use of a concept of a switch server. A switch server is just an integration server, and internally it keeps a list of all agents that is registered to it. So if you've got a flow running somewhere, you need to associate an agent with that flow, and that agent then needs to point to the switch server so that it can register itself inside the switch server. If you've got the other flow that may be the target of the calling flow, it will do exactly the same. You will have an agent that's associated with the integration server where that flow is running, and that agent registers with the switch server. When this calling application then calls via its agent to the second flow out there, the agent goes and passes the call to the switch server. The switch server look at what is the target that it needs to call to. There's a unique ID in there, and it finds it inside the list of the switch server, and then knows how to route to the correct receiving application. Okay, now let's move forward. So I prepared two message flows. The first message flow I will call it my caller application, and this application accepts a REST call. In a previous video that I'll put a link up, I will show you how to exactly create a flow like this that will accept a REST call. Inside the operational area, I've got two compute nodes. That's really not doing much, just to show that this is where you would typically add some data in there. But if I open up those compute nodes, you just see I'm just copying my input to my output and move the data to the next node, and exactly the same for this compute over here. Inside the palette, if you look at callable flows, I've used these callable flow invoke node in this flow here. This is where I will jump from this flow and execute a message flow in a different integration server. And when it's done in that integration server, it will actually return here and then continue the flow. So we're really breaking up the work that we want to do in two different flows. Inside this callable invoke, there's a few parameters we need to set on the properties. The first one is the target application. It needs the application name of the second flow. Now my second flow is down here. You can see it's called Callable Flow Target. If I double click on there, you will see I've got a very simple flow here as well. I've got from the Callable Flow palette, I've got the callable input and callable reply node sitting on the end. And inside my compute node, I've got a very simple instruction. I'm taking the data from field 1 and the data from field 2, and I just add them together to give an answer, and I'm returning an answer. So if I look at how my data looks like for my input data, if I open up this flow, you can see here is my input data. There is my output data defined using field 1, field 2. This is the two fields I'm going to add together, and I just apply it inside my output data as an answer. So going back here, my callable flow invoke. So I need the name of this application is running there, so that's what the target. And then I need a unique endpoint name and I've called it call 1. And the only thing I've changed in here is I've made my request timeout, instead of the default 120 seconds, I've made it 20 seconds. Now this call 1 needs to match in my second flow. Here's my second flow. This is my callable input node. There is that match. You see there's my call 1 sitting there. And there is the call 1. So that's how it matches those two to move forward. The demonstrations in this demo will go around 5 implementation scenarios. Just in short, what my pictures mean: there's the callable flow invoke node, there's the callable input node, and the callable reply node that I'm going to use in all of the scenarios. In this first scenario, I'm going to deploy both flows, the one with the callable flow invoke node and the target application, in the same integration server. You will see that you don't need any other artifacts to make this work. Here are my 2 message flows, and what I'm first going to do is I'm going to deploy both of these inside the same integration server. You see there, I've got the server 1 inside a node called node MQ1. Successful. I'll grab the second one, and I also deploy it inside there, and that is successful. So I've got both of these flows running inside the same integration flow. Now when they run in the same integration server, then you don't need anything else for these 2 message flows to talk to each other. If I go back in here, you can see that my endpoint is callable. This is running on my local machine. If I go back here, my HTTP input node, there is my suffix for the URL. And I'm going to use Postman to call these. If I go into my I've set up, I'm going to call my localhost port 7080. There's my callable flow version 1, and there's callable. So if I call it like this and I give it a value here of say 11 and 8, I would expect to get an answer of 19 of what is returned to me. I'm going to send, and you see there's a successful completion of this flow. So I've called the one flow, it jumped to the second flow, returned from the second flow, and then continue. In the second demo, I'm going to deploy the 2 applications, flow 1 and flow 2, but I'm going to deploy them on 2 different integration servers. For this to work, the integration servers needs to run inside the integration node. There's also the concept of a switch server that I need to deploy, as well as the definitions of the 2 agents, 1 each for every one of the integration servers. Now, if I remove this target from this integration server and I deploy it into a second integration server on my machine, so there's my callable target, I deploy it. Now you see inside the node with the name of node MQ2, and there's a server in there, server 2, and I've put my target in there. Now these 2 flows is actually running in different integration servers, and they don't know about each other. So if I go back to my Postman and I call now send, you'll see I'll get a return code that says error detected whilst processing a message in this node. An error has occurred while calling a flow registration not found. It gives me some error numbers and so on. So for the callable flow, so I can see there's my flow target, so it doesn't know where to find target. To make this work, you need an intermediary integration server. This integration server is called a switch server. I'm going to show you how to create this switch server on-premise. Remember, we're only talking on-premise at the moment. I've got an empty directory here. There, you see there's no files in it. To create the files necessary for a switch server and to create what we call agents, I need to run the following command. I don't need to specify the directory because I'm inside the directory that I'm running at the moment. So there's a command iib create switch config / hostname, and my hostname is localhost, and it's going to create 3 files for me. The admin client.p12 is just a placeholder at the moment, but you'll see there's a file called an agent.x and a switch server. Now this switch.json is the file that you need to create this intermediary integration server called a switch server. Everybody then with an agent can have this agent point to the switch server. When these flows then talk to the switch server, it will know where to find the other flow that is running as part of this callable flow. Okay, so for now, I'm going to first do a mqsi list to show you what is running. And you see I've got 2 nodes, node mq1 and node mq2. So if I run the following command, iib switch, create for me a switch, and use for me the config of this switch.json file, it's that switch.json file, it will create the switch server for me. Be patient, it takes a few seconds to do it. If I do now an mqsi list again, you will see I've got an additional integration node now running. It's called aswitch_node_v11 is now up and running. So that will act as the switching mechanism for the flows to find each other. How does the flows know where to find this switch server? You need to do mqsi change properties. I need to run the change properties first for my node mq1, goes into my integration server 1, and you specify an object of com ibm iib switch manager. It is of type agent.x config file, and use agent.x.json. Remember that file that was created here, the third file. Enter on that. Oh, sorry, I forgot, you need to stop your 2 servers. I'm just going to do it from here. Okay, I've stopped both of my nodes now. When I jump back in here, now the command should be successful. I also need to do it for the second node. So you remember I've called this node mq2, and there was a server 2 running in there. Enter on that, and I'm just gonna restart my integration nodes. Just to refresh, inside my first integration node, inside integration server 1, I've got the call side of my 2 flows, and in server 2 I've got my target side of these 2. And remember, I've got now my switch node running as well. And with these 2 setups here, with the mqsi change properties, I've pointed both of these integration servers to point to the switch server. Now let me try and do this postman call again. If I can do the postman call, send, and there's a correct answer. Just to show that it's actually online. 11 and 9 should give me a 20. There you go. So this is how you would set it up if you're running on-premise callable flows. In the next part of this demo, I'm going to show you how to split this between, first of all, we're going to run both of these inside Cloud Pak for integration, and then I'm going to run the calling part on premise, calling the target part that's running in Cloud Pak for integration, and then the other way around as well. In the third example, I'm going to move the same flows without any changes. I'm going to deploy it inside Cloud Pak for integration. You will see for that to work, I need to create a switch server, and then the flows themselves, as I deploy it with access to the switch server, will generate two agents that register with the switch server. In the next part of this demo, I'm going to deploy both of my message flows on the Cloud Pak for integration. So I'm going to start by just deleting the flows that's running on premise, just to make 100% sure that we don't get interaction from these two. I'm going to start my Cloud Pak for integration here. I've already created an App Connect dashboard. To deploy flows, I'm going to first add my bar files for ease of use into my repository. I'm going to say import my bar files. This is actually where the two bar files is sitting on premise. So I'm going to import the calling side, and I'm going to import the target side. Before I can deploy my integration service, I need to go and create that switch server, that communication medium. I need to open my OpenShift console. I'll go to my operator, look at my installed operators, and the switch server is part of my IBM App Connect operator. Right at the end here, I'll find App Connect switch server, and there's create switch server. It will present to me some YAML. It's a switch server. I can call it a different name. Let's call it VDM-switch server. For my licensing, I need to accept licensing. And the rest I can leave as is, and I can say create. Go back to my App Connect side, servers. Now I can create a server. It will be a toolkit integration. Next, I can select the callable side. Next. Now I need to go, you will see there is the switch server. Is now part of my configurations. It will have a type of agent X, and the first bit will be VDM switch server, and it's appended with agent X. I need to select that. So it will deploy this agent X with my integration server. Next, I'm going to call this a new name, VDM, and let's say that is the calling side. I only need one replica and create. I also need to create the target side. Remember, I'm going to deploy both in the same Cloud Pak for integration. Next, I can select my target bar file. Next, again, I need to create, select the same switch server. Next, I'm going to call this VDM-target. I only need one replica and create it. This can take a few minutes to become available. Please, you'll see here it says unavailable, and you'll see there a view error. So you can click on that, and it says find out more by looking at the ports, etc. You know, just wait, it will come alive, and it'll go back to a started state. It won't do it automatically. You need to actually click the little refresh button from time to time to see when it is available. Of course, you can go to your OpenShift platform, look at the ports, and see which ones. You see there's my EVDM calling part, should be up and running now, and I guess the target one will start very soon to deploy. I can go back to here, do the refresh again. You see the calling part is started now. We're still waiting for the target site. And if we just refresh again, let's see. Yes, now my EVDM call and EVDM target is actually both started. To find the endpoint of the REST call, I need to click on the integration server. There is the endpoint that I need to call. I'm going to copy it, get into my Postman, and I'm going to paste it down there. There's one too many one at the end. I'm going to make sure I put in some different values here. I'm going to send it, and I get an answer back of 20. So deploying both of these servers with the assistance of that Agent X will allow them to talk to each other. Now we need to start to think about what are we going to do if we want to deploy one of them on-premise and the other one inside the cloud. In the next example, I'm going to deploy the calling side of the flows on-premise and the target side on Cloud Pak for integration. You will see that we will reuse the switch server that was created in the previous example. Now we do have the switch server that has been deployed now inside Cloud Pak for integration. So I'm going to delete this integration server because I want to deploy the calling side on-premise. If I go to on-premise, I've got my server there. There is my call side, and I deploy it inside server 1. Now, this server actually does not now know where is my target side running, that is running somewhere on Cloud Pak for integration. So if I go to Postman and I try to call my local one here, and I say send, you will see it actually does not find the server that's out there. To find that, I need to actually find an agentx.json file that is part of the switch server. Now remember when I created the on-premise version of the switch server, if I do a dir here, it created these files for me. I was really interested in the switch server and the agentx down here. So the challenge is for me to find the agentx.json. Now for my on-premise calling side of the message flow to communicate to this the target one that's running here, it needs to talk via that switch server, and it needs to register with that switch server with the agentx.json file. Now when this server started up, it would have used the same agentx.json file to register with the switch server that's running on Cloud Pak for integration. So if I go into OpenShift and I go into my pods and I look where was my target deployed, there was my target, there's the port from my target. If I go in there and I have a look at the logs, if I look inside the log, I can see down here starting agentx with a config folder, and there is the folder where it found that file. So if I can get my hands on that file, that means that I can use that for my on-premise registration as well. So I'm going to copy that. Let me just go have a look. If I go into the terminal, if I say change directory to that directory, and if I do an ls in there, there's my agentx.json file. So what I do need to do is to copy this file to my local server. Now to do that, I go in here. I've previously logged on with an OC login to my cluster. So if I say OC projects, just to see if it is still running, unauthorized access. Okay, so I need to go and say copy my login command, keep admin login. Display the token for me. Copy. Then I can say OC project, and I'm trying to talk to IBM Cloud Pak for integration project. So the copy command looks like this. I need to find out what is my pod name. I can go back in here and I can say OC get pods, and I can see from here that my pod name is this one here, EVDM target. Alright, so I'm gonna copy that, replace that in here. Okay, and the name, the folder where it needs to copy it from, I can get this from the logs. It is that. And I need to append the file name agentx.json in there. /file. And I'm going to copy this file to this place on my hard drive. I think I've got an old one there. Let me just go and delete it. Yes. And let me pull that file with an OC copy command. So the start.json, yes, it is back. And now I must register this agentx file as the agent file to point to the switch server that's running on Cloud Pak for integration. To do that, it is again this change properties command. It's running in node MQ1 server 1. Let's just make 100% sure. There you go, node MQ1 server 1. But remember, to run this command, I need to first stop my node. It is stopped. Run the command. Because I changed properties. Oops, I'm in the wrong file. I must actually run it from my console. It's done. I need to restart my integration node. And now it will pull in that change property settings I've done. it will associate that agent X file, and that agent X file will point then to the switch server that's running on Cloud Pak for integration. Now I can go back to Postman, and I can do my call again. Remember, before I've set up the pointer to the switch, it gave me an error. I can do a send now, and there I'm getting a correct answer back. So this means now the calling application is running locally, and I'm actually calling into Cloud Pak for integration. And in the last example, I'm going to just flip the two flows around. So the calling portion will run inside Cloud Pak for integration. The target side will run on-premise, and we will also reuse the switch server as in the previous two demos. So let me delete this file from here, and let me go back to my App Connect. There's my integration server. I'm going to delete it. I'm going to deploy the target side now locally. But now, remember, this integration server has still got access to that agent X file that has been deployed inside server 1. So it should have still a pointer to the switch server. If I go back on the cloud, I'm going to create now the calling side inside my cloud. There's the calling side. Next, I grab my agent X. Next, I'm going to call this fpdm-call. I only need one replica for it to run, and create. As before, I just need to wait for this integration server to be created and to deploy that bar file in it. There you go. Remember, this is now going to be my calling side, so I need to find out by clicking here what is my endpoint. There's my endpoint. Copy that. Go back to my Postman. It's not an on-premise call anymore. I'm going to try and do this one now. And let me change the value in here. 11 plus 10. Send. Oh, there's a mistake here. I've got two HTTPs in here. There you go. Let's do the send again. There you go, comes back a value. So you can switch those two files around without changing any of the agent X or the switch servers.